All right, on to diagnostics. So in this we're going to cover method cache statistics, method error analysis, and some changes to Jade audit access. All right, so method cache statistics have now been added to the Jade monitor, which allow you to display these stats for any process or all processes on a node. These statistics can be useful for determining the appropriate method cache size and also when attempting to diagnose performance issues. To access the statistics for a particular process, you can go to the user activities from the navigation bar in the Jade monitor, right-click a particular node or process you want to interrogate and select the method cache statistics option. This will take you to another form which will display the stats. The information tab. And so included in these are the maximum cache size that's been reached, as well as total methods in cache, the total amount executed and total discarded, as well as the total time it's spent loading these methods, as well as the number of, if any overruns have occurred, which is when the current call stack's been greater than the allocated cache size. It'll show you, and it will show you how far over the cache limit it's reached in each overrun state. So 2 new methods have been added to the process class to facilitate this new functionality and are available to use. These can be used to programmatically interrogate a particular process and see what its cache is up to. So the process get method cache can be used on an executing process to retrieve its current method cache states in the form of a Jade dynamic object, which has all the values stored inside it. And also process send method cache statistics can be used from executing code to access the statistics from any other process, and this is done via notification. So beforehand, where you're executing the code, you would need to register for the process method cache stats event notification on the process class instance. And so the method cache itself has had an update in an attempt to increase its performance without the need to mess with your cache size any settings as much. So the caching algorithm has been changed to include a lifetime value, which basically means when previously a method was due to be removed, it will check if it's reached its specific lifetime yet or not, and only remove it once it's reached that. So the idea behind this is that it will limit the amount of times methods need to be loaded into cache, which in turn means less method lookups and less CPU usage, and it should be faster. And so the lifetime value can be modified using the method cache lifetime value in the Jade interpreter section of your ini file. And so the default value there has a lifetime of 10 minutes for 64-bit nodes and no lifetime on 32-bit nodes, so no change for 32-bit nodes. In addition to this, we've also changed the default method cache size from 512K to 5 megabytes. And back to Tim. Nope.
Alrighty. Now, as Bob mentioned before, method error analysis. So this essentially, we put this on diagnostics rather than development environment. It really could fit in either section, but development environment is really big and the section was really small. So we've moved it here. Method error analysis. This is what I call red squiggles. This is when you're typing away and you've made a little bit of mistake in your code. Maybe you've forgotten a semicolon at the end of the line. It's always something I quite embarrassingly do. Feels kind of bad when that happens. So it's good if it points it out straight away so that you can fix it up. So the idea is that as you're typing, anything that would create a compile error, rather than waiting for you to compile before telling you about and giving you the compile error, will actually now tell you about it as you type in the form of a little bit of red squiggle underneath the erroneous code. First of all, it's enabled by default. If you really hate red squiggles and you want to get rid of them, in the the editor options before method error analysis, on by default, you can turn it off if you don't like it. So what's it going to look like? Let's say that you've got a really simple method here and you've got VA space RS. That's not variables list at all. You're going to get a red squiggle, and if you mouse over that, it's going to tell you exactly what it found wrong with it. So error VA expecting a method section name. Okay, that's pretty useful. So you can go, oh, of course, VA isn't a method section name, and you can fix that up. Note you'll get a slightly different method than if you, a slightly different message than if you actually compiled. If you compiled and you got the error 7105 expecting begin, see that's slightly different. It's not actually doing the compile. What it's doing is it's just kind of reading your code as you go and trying to spot anything wrong with it. So some of these messages will vary a little bit. Now, as well as that case, another example what I can do for you is you're, let's say that you're assigning a variable. It'll know what type that variable is supposed to be, assuming it's declared already. If you try and assign something to it that isn't the right type, it can let you know about that. So you'll see that I've tried to have this string name. I've tried to assign it the number 5. I'm going to get a red squiggle under the assignment there. And if I mouse over it, I get operator is not valid for type. And then if I had compiled that, that would have given me a 6072 incompatible types. So as you'll see, anything that would give you a compiler error if you compiled will give you a red squiggle without having to compile. So ideally, when you come to compile, you should pretty much never get a compiler error because you should have already seen it from your red squiggle, your method error analysis, and been able to fix it without having to constantly spam your F8 key. Now, just to kind of give an example of where, because the message is going to be slightly different because it's not actually doing the compile, sometimes it can actually still pay. If you're not quite sure what you've done wrong, you can actually get a bit more information from compiling. This one example where I've forgotten a semicolon. So I've got name equals my Fubert Bartholomew, haven't put a semicolon, and then I've tried to write the name. So what it's going to do is it's going to identify, hey, write isn't a reasonable thing for you to be putting here. It's going to give me an invalid syntax. The compiler, because it actually gets to do the compile, will have access to a bit more information, and so that's a case where it can actually tell you specifically what you've done wrong is, oops, you should have put a semicolon there. So most of the time, if you get a red squiggle, it's going to be really obvious what you've done just by looking at it. If you're not quite sure, you can mouse over it, and that's probably going to tell you what's up. If you're really still not sure, you can still do the compile, of course, to get the compiler error message. Now, the last one is actually just kind of a small one because we're about to have lunch. Jade Audit Access, pretty much you can now identify OIDs that are added to and removed from collection block update records. So we've just got a couple of extra methods on Jade Audit Access. Get collection block OID, get collection block OIDs for all of them. You can find out if the description class is a subclass, and you can get a superclass number. So those methods do that. You can now identify OIDs added to and removed from collection block update records. I'm going to keep it kind of brief there because I believe it is now time for some morning tea.